Section 2.5, derivatives of trig functions. All right, let's start out here saying the derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, derivative of cosecant, negative cosecant cotangent, derivative of secant, secant times tangent, and derivative of cotangent is negative cosecant squared. All right, you need to memorize these derivatives. Going to use them a lot in here. You're going to use them going backwards here, basically, at the end of the semester. Then you're going to use them again in Calc 2. If you're going to take other Calc classes, you'll probably see them again. All right, so I told you to memorize this. Let's see if we can kind of think of some stuff that'll make this a little easier, okay, to kind of group it together to memorize. All right, first of all, let's talk about the negatives versus the positive sides. Every time we're taking a derivative of a trig function that starts with a c here, like this one, and this one, we're going to have negatives. Okay, so every time we're taking a derivative of something that starts with c, it's going to be a negative. All the rest of them are going to be positive. All right, now, kind of thinking a tangent and the cotangent together. Tangent secant squared, and then cotangent's negative cosecant squared. Think also of cosecant and secant. If we take the derivative of both of those, they have themselves first, and then some other stuff, okay? So try to put that together. Try to memorize it some kind of way in your own words, or make up some kind of sentence or whatever to make this easier to memorize. All right, so we're going to use this stuff. Let's see. Suppose that we're looking at the handout and we come across the first one. First example, we have d over dx, or derivative with respect to x of cotangent of x. Oh no, that's not the first one. First one is this. Find dy over dx of y is equal to x times the cosine of x. Find dy over dx if y is equal to x, cosine of x. All right, so let's see. I want to find dy over dx. Well, what I see right here is that I have a product. So I'm going to use the product rule, which we learned in the last section. We said if we have two things multiplied, we can think of it as first times the derivative of the second times the derivative of the second plus the second times the derivative of the first times the derivative of x here. So x just comes down here. But what did we say the derivative of cosine was? We erased it, right? We said it starts with c, so it's going to be negative, and it's going to be sine of x. Plus the cosine of x times the derivative of x is just 1, right? So what does this give me? Negative x sine of x plus cosine of x is the derivative of that function. Let's look at our second example. Our second example is going to look like this. Find y prime. Find y prime if y is equal to 5 minus cosine of x over 5 plus sine of x. 5 plus sine of x. So if I'm going to take the derivative of this, which rule will I use? The quotient rule. So let's see. What did they say? Find y prime? Yeah. So I'm going to call this y prime this time. All right, so for the quotient rule, the denominator times the derivative of the numerator minus the what? Numerator times the derivative of my denominator all over my denominator squared. So here we get 5 plus sine of x, just drops down, Derivative of 5 is just 0, right? But what's the derivative of cosine? Okay, think about it for a sec. I have a negative that came down, right? And then the derivative of cosine is what? Negative sine. So if I put another negative in front here, it's going to make it a positive. Minus 5 minus cosine of x times derivative of 5 is 0, but what's the derivative of sine? Cosine of x. All over 5 plus sine of x squared. Alright, I don't really need this plus anymore, do I? So I distribute the sine of x through here to get 5 sine of x plus the sine of x squared minus, let me go ahead and distribute the negative and the cosine at the same time. So minus 5 cosine of x plus cosine of x squared all over 5 plus sine of x squared. All right, what do you think about this? What if we got this sine squared together with that cosine squared? Couldn't I use an identity to replace that and make it simpler? So let's write 5 sine of x. Bring this part down. Next, we're going to bring down, I don't know, maybe this minus 5 cosine of x. And then we'll bring down plus sine of x squared plus cosine of x squared all over 5 plus sine of x quantity squared, like that. Now what can I call this part to make it simpler? I could call that 1. So I'm going to say it's equal to 5 sine of x minus 5 cosine of x plus 1 over 5 plus sine of x squared. There's my y prime. There's my derivative. Let's look at what we have next. Next we have this one. They want us to find the derivative with respect to x of a function that looks like this. So they have find the derivative with respect to x of cotangent of x over 1 plus cosecant of x. Alright, so I'm going to use the quotient rule right here. I'm going to say this is equal to, how do you take the derivative of quotient? Denominator times the derivative of the numerator, right? Minus the numerator times the derivative of the denominator all over my denominator squared. All right, let's keep going. 1 minus cosecant comes down. I'm sorry, 1 plus cosecant comes down. How about our derivative of cotangent? It's going to be a negative, right? What's the derivative of cotangent? Cosecant squared, right? Minus cotangent of x times, how about the derivative of this stuff? Well, derivative of 1 is 0. What's the derivative of cosecant? Negative cosecant of x times cotangent of x all over 1 plus cosecant of x squared just comes down. Well, let's see. If I go ahead and distribute this cosecant squared in here, what am I going to get? I'm going to get negative, if I can write, negative cosecant of x squared, because we multiplied by 1, minus cosecant of x, but this time to the first times squared gives me cosecant cubed, right? Plus, because the negative times the negative gives me cosecant of x times cotangent of x squared, right? All over 1 plus cosecant of x quantity squared. What could I do with that? Well, right here, here, and here, you have a cosecant of x common to all of those. So I'm going to factor it out. I'm going to factor it out of all of those. And I don't know, if it leads with a negative, for some reason I like factoring that negative out. So out of my numerator, I'm going to factor negative cosecant of x out. So if I factor a cosecant of x out here, I still have a cosecant of x to the first. How about for this term? If I took one of them out, I still have cosecant of x squared, right? Now what sign do I need there? Negative times what gives me a negative? Positive, right? How about here? If I take a cosecant out there, I have what? Cotangent squared. But negative times what sign gives me a positive? That'll be a negative. Close off my parentheses. That's my numerator. Over 1 plus cosecant of x quantity squared, like that. Alright, let me see if I could do something in here. Especially with this cosecant squared, cotangent squared, stuff like that. Let me think about my identities. What do you have for Pythagorean identities with like a cosecant and a cotangent? Remember this one? 1 plus cosecant squared is equal to cotangent squared. So I can make a replacement, right? Hold on. 1 plus cotangent squared is equal to cosecant squared. I can make a replacement then. Couldn't I call this part right here 1 plus cotangent squared? So let's do so. Let's come over here. We'll say, okay, we have negative cosecant of x. Then we have cosecant of x from here. And then right here, we're going to call that plus 1 plus cotangent of x squared instead of cosecant squared minus cotangent of x squared that comes from here all over 1 plus cosecant of x quantity squared. So in other words, this part became what? That part, right? This negative cotangent squared came over here. Now these two are going to zero out, right? So what I'm going to have is negative cosecant of x times cosecant of x plus 1 over 1 plus cosecant of x quantity squared. And isn't this really the same factor as that one? So I can divide out this with one of these. Then I'm left with negative cosecant of x over 1 plus cosecant of x as my derivative. Now, a lot of time on these trig ones, there's more than one way to write a correct answer, especially that you can use identities and stuff. One more thing on Wiley. If you ever enter in something like sine squared, you have to enter it this way in Wiley plus. You have to write that as a sine of x quantity squared like that.